this session, if that's okay with everybody, and then I'll publish on our YouTube channel as usual. My name is Stefano Tempesta. I've been running this meetup for some time, where we look after robotic automation and application of artificial intelligence to the industry. And today we'll focus on confidential computing or confidential cloud use cases. I am very pleased to have with me two professionals of this space. Ben-Ari, founder and CEO of Applied Blockchain, and Amar, Gowda, product manager with me and Microsoft in the Azure Confidential Product Group. So who best than these two gentlemen, talking about preserving privacy in open banking, and then a use case of confidential computing. So I'll leave it to Adi first to go through your introduction, your session, and then we switch over to Amar for a broader presentation of use cases for confidential computing. So Adi, the stage is yours.
Okay, thank you very much, Stefano. Can you allow me to share the screen? I have some slides and I'll show them to the...
You're right. Yes, do that in a moment and you can go now.
Okay, very good. Thank you. So my name is Adi Ben-Ari. I'm a founder and CEO of Applied Blockchain, as Stefano said. We are generally a consulting company, so we do projects for companies and we specialize in blockchain and also in privacy technologies like confidential computing. And in the case of silent data, we built our own product. So we've actually built a platform here, which I'm going to show you. And it's really an example of what we think can be built using this technology. So I'm going to speak to the use case more so than the technology, but hopefully that will give you a good feel for how this technology can be used and some of the potential. So the product that we have is called Silent Data. It's a SaaS platform. It's a software as a service. And it enables privacy-preserving checks on bank accounts belonging to individuals and companies. So first of all, I guess what's the problem we're trying to solve? Well, if you're dealing with other people, with other companies, there are situations where you want to know a bit about their financial health, right? If you're providing credit, if you're lending, or if you're exposing yourself by providing services perhaps to a customer and then they're not paying you until the end, you're taking risk, then it can be useful to understand whether that individual or company is going to be able to pay you and what are the chances of them being able to pay you. And one way of understanding that or reducing the risk is to be able to perform a check on a bank account. Now, this isn't really the kind of thing that happens today very often. It only really happens in lending. And the reason is it's because accessing this data is quite difficult, or has been up until quite recently. So if you wanted to check the financial health of an individual or company, up to now it's really through asking for bank statements. And that's what we normally have to do when we apply for a loan, for a mortgage and so on. Now, the problem with bank statements, of course, it's paper, it's slow to transfer and to find and to submit and so on. And also it's easy to doctor. So anybody can print anything these days. And if it's a PDF, a scan of a document, it's also very easy to forge or to change and so on. So it's not a very reliable check. And given that this is being used to manage financial risk, that's not a great situation. So one innovation that we have over the past few years in a number of countries is what we call open banking. And this really started in the UK and in the EU, in Europe, where the financial services, the regulator, the government, they forced the banks, the big banks, to expose a set of APIs and allow startups, fintechs, third-party application developers to have access to bank account data through APIs. And this is with the permission of the bank account holder. So from a technical perspective, this is normally implemented through an OAuth type flow. So a bit like logging in with Facebook, Microsoft login and so on. You log in to using your bank account login credentials. You give permission to share your banking data with a third party, and the third party is then able to call the APIs and retrieve the bank data. And that's what we call open banking. As I said, in the UK and in the EU, this is something that was mandated by the government, and so they forced the banks to implement this by a certain date. And now it's implemented throughout the UK and EU. In the US, it's become an industry-driven initiative. And so there are companies that basically aggregate the bank APIs, and many of the banks offer the APIs. And now this is something that's prevalent and widely available in the US. And I guess the other jurisdictions where we're seeing this starting to come through, Australia and Canada. And lots of other jurisdictions are talking about this because it's seen as an enabler for fintech and for competition and innovation in finance and banking. So open banking is an option for checking bank account data. So if we wanted to do the checks that I described earlier, we could do it through open banking. Yeah, the problem with open banking, though, although it's a fantastic opportunity to get to the data because we have these APIs, the problem is this data is quite sensitive, right? If it's an individual, then there's all sorts of things in the banking data, people's habits. Do they go to a casino? Have they visited? Have they watched certain types of content? I don't know, all sorts of things that people might not want to share with everybody. And if it's a business, then there's also a lot of very sensitive data there, right? What is the business paying each employee? What is the business paying to suppliers, right? Maybe some suppliers are being charging different amounts. What are the customers paying, right? Maybe a lot of businesses will charge different prices, give discounts, and so on. So there's some really sensitive information in the bank account, which, if it got into the wrong hands, would be really damaging to either an individual or to a business. So we kind of see this tension between having the data available from the APIs, but on the other hand, this big risk around it. And also with these open banking APIs, people are resistant to using them because they perceive a security risk and a data privacy risk around the data. So if I log into my bank account and give someone else access to my bank account data, that feels very, it doesn't feel very secure, right? It does feel like I'm letting someone in to somewhere where they probably shouldn't have access. And as I said, if the data got into the wrong hands, that could have a lot of negative implications. Examples, a lot of you will probably be familiar. There's some very big data breaches that have happened over the last few years. Probably one of the most notable when it comes to financial data was Equifax in the US. 148 million Americans' financial data was compromised. So taking data out of a bank and putting it somewhere else, it's risky. It's hard enough to secure inside the bank, let alone outside. So what if we could perform these checks without actually having access to the data, right? And obviously we're in a session about confidential computing, so there's a hint there about whether this is possible or not. The types of checks that we're talking about, so if we're looking at the bank account, can we prove that there's a balance in the account above a certain amount, right, without knowing the actual balance? Can we prove that there's been consistent income in the account? So maybe, can we prove that someone has a salary above £1,500 in this case? Maybe their salary is £10,000. We don't know that, and we don't need to know that. We just need to know it's above a certain figure, and so on. So can we prove thresholds, for example, about the bank account and about the behavior of the account? Maybe prove that the company's revenues haven't gone down drastically in the last few months, so prove that they're not in trouble. Prove that someone isn't, in too much debt. Whatever it is we want to prove, can we get a more or less binary answer to that without having to reveal the underlying banking data or without having direct access to it? So this is what we addressed, and so we built this silent data platform. And what it does is it connects to these open banking APIs, and it connects from a secure enclave. And we're doing this using Intel SGX, and we're running it on Azure on a confidential computing machine. And we're connecting directly from the enclave to the Open Banking API, retrieving the data from the bank directly into the enclave. And that means that our server, our virtual machine, doesn't have direct access to this data. The admin doesn't have access to it. Microsoft doesn't have access to it, even if they wanted. And so the data it's as if it was still in the bank for all intents and purposes, because it's in this hardware secured environment. But on the other hand, we can run queries, predefined queries in the enclave. Those queries, if somebody was really paranoid and wanted to know what queries are going to be run on this data, what can we do with it? The source code that we run in the enclave is available, and we can prove that the enclave is running our source code. And this source code, before they submit their data, and also when they retrieve it, we can prove that that's the code that was executed. We have this attestation from Intel, and it's going to be an attestation from Microsoft because they're transferring the service. But that attestation is an independent attestation that says, yes, this is a secure enclave, it's got the Intel chip on it, and this is the code that's running there. And so we can generate proof from the enclave that the data came from the bank, that the query was running, that the data was retrieved into the enclave, that the enclave has a secure code base, that specific code which we point to is the code that was executed in the enclave. And therefore we can prove that the outcome is a correct outcome based on the bank account data, and that we couldn't have accessed the data ourselves. And so we can prove all of that without revealing anything except the answer to the query. And that's what comes back from the enclave. And we package that up in what we call a proof certificate. And that's really a name that we've made up just to try and explain to people what this output from the enclave is. And we present it in a certificate format, and it basically has the answer to the query. So it's got the account holder name. This is data that we choose to publish. We don't treat this data as private. We say the answer to the query, so we have consistent income over 3 months of over £1,000. And we have the cryptographic proof to prove all of those things that I just said. And they sit behind that. That's what sits behind the certificate. And there's no other data available in the certificate. So there's nothing about the underlying banking data. We could never access it, and it doesn't have to be accessed by this party. And the artifacts that we retrieve from the enclave can be verified independently offline by anyone who chooses to. So it's a bit like verifying a certificate. So you don't need to connect to our service. You don't need to connect to Intel or Microsoft. You don't need to connect to the bank in order to verify the certificate. It's just like verifying a regular certificate. And sorry, I'm just gonna, I can share with you the actual, what the actual application looks like here. I'll switch over here. Can you still see my screen, yeah?
I can see that, yeah.
You can see the application, right? So this is our application. It's in production. It's been security audited. We've even taken this thing through the FCA, which is the UK regulator, to make sure they're happy with it. So this is an example certificate, right? This is a real certificate that was run on our company bank account, right? And it shows that it shows that the company is getting more than £1,000 a month, right? Doesn't tell you how much we actually make as a company. We have a shared version of the certificate, which is just a URL that we can share with that you might want to share with someone who wants to have proof that this information, this is correct about the company. They can also download the outputs of the enclave. And let me just show one final thing. We have a facility to independently validate that downloaded proof. So we basically created this GitHub tool, which is completely open source, where you can just upload the proof. and this is the public data. And then this is the proof with the signatures, with the enclave artifacts, and so on. And this will run a verification in the browser using this open source code, and it will return the status of each of the checks that's run. And that means that you don't have to trust us, you don't have to trust our service, you don't have to trust our servers in order to know that the answer to this query is true and valid. And that's really that's what we think this this technology enables. It enables you to be able to create verifiable proof of properties of data without actually having to share the underlying data. And that means in this case you can have these financial health checks. There's no data sharing in terms of revealing any of the data. And therefore all that risk around the data sharing goes away. In the UK, in the EU, we have Gdpr, which is the government policy and protection around data, which is very strict. And this allows companies to be fully compliant with Gdpr because it has a principle called data minimization, which means that you're only actually allowed to collect and process the minimum data that you need in order to run the organization, in order to execute your business processes. And through this tool, we're showing that you can perform these financial checks without the data, right? Without having access to the data. And if you take GDPR legislation to its logical conclusion, if you can do the checks without the data, then actually you shouldn't be collecting the data. And so this is the direction that we think this is going in. The fact that you can do these things without, you can now perform checks and do a lot of work that you could otherwise only do when you hold a copy of the data. You can now do without that, and we think that's what the legislators and regulators are going to want. We also think that's what customers are going to want, because that provides them with less risk around their data. And we think eventually, the companies themselves that are performing these checks or collecting this data, we think many of them will eventually go in this direction as well, because this reduces their risk and their liability. So by collecting a lot of data, you're creating this honeypot for cyber attacks as well. And if you can run your business and you can do a lot of what you need to do, again, without holding copies of all this data, then you're reducing your own risk as well. So we think that once customers see and understand that these types of activity, these types of checks, this type of computation is possible with their data, and it offers them such a higher level of protection, we think that they'll demand it. This particular tool with the bank account checks, we've already been in a lot of conversations with finance teams, companies that do lending, trading platforms that want to be able to offer credit to people that trade. I want to be able to make these bank account checks. And this is a safer way for all these different companies that need to do these bank account checks to perform them without having the risk around the data. This is a little bit about us as a company. So this is the team and some of our investors. We work very closely with Shell, which is an investor, and we have some VC as well. And in terms of clients, these are some of the companies we've been working with, and we've taken this to. We've also published our own report about confidential computing and how the technology works and what's possible and so on. So there's a link here which I could share, which kind of gives a little bit of the research that we've done. That's it.
Thank you. I think that was a great overview. I have a quick question. So you mentioned that your company, Applied Blockchain, is part of the confidential consortium, confidential computing consortium. Yes. What's your role? What is consortium doing exactly?
Yeah, so the consortium it's a group of companies which are working with this technology and really looking to define standards. Right, so within the consortium, you have, of course, Microsoft, Intel, also companies like Google, Facebook, and so on, and also companies like us. Now, the larger companies they're obviously developing the infrastructure for this, such as the Azure confidential computing platform. And I think there's a push to try and standardize the environment, some of the technology, how these checks are performed and presented, the development environments. So, for example, there are some common libraries which have been created, which abstract the underlying microprocessor manufacturer. So in practice, when we've been building this, we've had to work very closely with Intel and the Intel low-level libraries because that's the level at which the functionality in confidential computing was exposed. But now within the confidential computing consortium, there are libraries being built up which work at a higher level and abstract some of that low-level programming and still allow you to develop applications probably more quickly in a confidential computing environment in a more standard way. So that's the aim. The aim is really to promote the technology, to promote standards, to get the different parties to work together. And we as a company, we're really, we're small guys in this. We're there to really observe, understand, see where this is going, and also have early access to some of this, some of the innovations and the collaborations that are happening in the space.
Beautiful. Yes. And if someone wants to get in touch with you, what's the best way?
Adi@applyblockchain.com.
Easy. Any questions from the audience? Feel free to unmute yourself or type in the chat.
Yes, so can I ask one?
Yeah, please.
Yeah, so you mentioned that you use attestation from Intel and Microsoft, right?
Yeah.
And
yeah.
I was wondering whether within the consortium, were you using or collaborating with Intel and Microsoft and reusing their solutions, or did you yourself also build something related to attestation on top of what Intel and Microsoft provides?
No, so with this technology, I guess there's different ways of using it, and I think the next presenter will also present a whole lot of other use cases. But what we needed from it, we needed a third-party attestation so that we wouldn't be a trusted party in generating these outcomes, right? So we didn't want people to have to trust us about whether the result of the query is correct or not. And in order to eliminate us from the equation, we have to be able to revert back to either to Microsoft or to Intel. Now, when we first developed this, it was still Intel offering the attestation service. So we developed using the Intel libraries, and we call Intel, and they return a response that provides the proof that it's an Intel enclave and the code is running there and so on. So they provide the Intel attestation, and that everything else is kind of anchored back in that. So everything else that we claim about the result of the query is really anchored in the fact that Intel has said that this is a good enclave and this is the code that's running there. Now, Intel doesn't really want to provide that service on an ongoing basis to all the developers. So now that Microsoft has developed a confidential computing environment, Microsoft is now kind of, well, I mean, the Microsoft team will be able to explain this in more detail, but Microsoft effectively offers that, or is going to offer that attestation directly. And then we won't have to go to Intel anymore. So that's just for the attestation service, but it will have the same effect because users of the system won't have to trust us. In other words, we won't be able to intercept these queries. We won't be able to forge them. We won't be able to influence them. We won't be able to see the data. But we are able to provide this as a SaaS service that's hosted by us. So I think that's a new concept. And I think it's very interesting. It means that companies can provide services without somebody else having to think that they're taking a risk by taking this service from them.
Okay, thank you.
Okay. Anything else? Anyone else? Great.
Back to you, Stefano.
Yes, okay. So thanks everybody. Let's carry on with the conversation. We have Amar from Gowda from Microsoft going through some use cases of confidential computing. Amar, over to you, and then let me see. You should be able to think, and we can say thanks to Adi. Yes, to go. So thanks, Adi, and we'll see you around next time.
Yeah, thank you. Bye-bye.
Okay, what do you folks see on the screen? Because it's a little weird for me.
Nothing for now.
All right, the multiple monitors is not helping. Okay. Anything now?
Yes.
Right, so you see the presentation?
Yep.
Okay, so let's see if I could switch this to. Okay, I may have to. Okay, I'll keep on this mode instead of wasting time with you folks. Okay, so if this is not readable, let me know. I'll try to zoom in a little more. Let me turn on my camera if I can. Can you guys still hear me?
Yep, we can still hear you.
Okay. So so let me kind of chat about what confidential containers are and what customers are trying to do here. You know, everybody knows containers is what is kind of ubiquitous in the market now. Everyone wants to containerize their apps, you know, do cloud native practices. So in today's next 15-20 minutes, I'm going to spend time on why you have to think about confidential containers, what you need to protect, and how, and specifically delve deeper into where. You know, where are customers leveraging confidential computing to solve business problems, and in and around why the case to that, right? So we are in this kind of in a phase where defense in depth for containers, or defense in depth generally for applications is inevitable, right? I think that we have heard a lot of cases because of attacks in different places, because of a lot of supply chain issues, because of some buggy code, or it may be hacking into the infrastructure or the runtime environments itself. So I think it's becoming very obvious that defense in depth, no matter what it is the way of doing it. And the other side of it is the zero trust modeling, right? I don't trust anybody, right? We should always start with zero trust and build a layer on top of it. It's all about removing the layers, or even if you trust somebody, how do you verify, right? So it's a trust plus verify. And the other side of it is with containers, comes container packing, right? You have a single node, you want to throw in a bunch of containers, but you don't have control over every container that is running per workload in a node, right? There could be one privileged container or something which is not behaving the way it should be, or it has a malware attack which you did not pay attention to, but the whole node becomes compromised. Hence, all of the containers there could be compromised, right? So the isolation and a tight process and hardware-based sandboxing is becoming critical. This is also true when you want to run multi-tenancy, which is very common with most SaaS. Now, Kubernetes is the way of running your microservices, and with that comes multi-tenancy, right? You have multiple customers running on the same cluster. You would see this like, okay, what do I do? How do I restructure my architecture deployments to fit into this? So in this couple of 5-10 minutes, I'm going to basically hit on these points, right? So the topics for the confidential containers and confidential computing is about code integrity, the data integrity, confidentiality of the data, and establishing a hardware root of trust. So this is how I box it too. I'm like, here are all the possible actors, right? We started with zero trust model. And here are all my folks in my trust boundary. It includes us, like Azure providers, hypervisor admins. It's also Azure in this case, but it could also be another cloud provider or generally on your on-prem as well. And you have Kubernetes administrators, which is obvious. Kubernetes administrators, plus you also have some domain admins who tend to have access to the nodes, can do a RDP or SSH to those. Those are also the actors that you need to worry about, right? And here is your container that is processing sensitive data, right? This is subjected to attacks from all of these, right? All of these are untrusted parties for us. And the other containers on the same node are also untrusted parties, right? This is the current situation. So this is just kind of painting the picture on the Azure side, who all are part of this trust boundary, right? On the left side, you have the host administrators, the service and the operators, like AKS as an operator provider, Kubernetes service. You have physical access at the data centers, and you have VM admins or the guest OS have access to SSH and RDP, as I called out. Everybody knows this is the world we live in. We are pretty feel safe about the data in rest with our own managed keys. We are good with the TLS and TLS 1.2, 1.3, and all the innovations that have happened to secure the data in transmit. And now we are looking into, okay, we probably left one other vector. It's a three-legged stool. And the third leg here really is data in use, because this is where all of the memory is unencrypted, right? Because that's how the chips are designed to process. And this is where confidential computing comes into play. Okay, so what it brings is it's a hardware based. Okay, this is a major difference between homomorphic encryption or other ways of encryption, where your software and the applications have to do the encryption and decryption anytime they do the processing. Here it's hardware based. That means the hardware will take care of that load of processing or rather encrypting the memory. So the only way apps are ever in the plain text for the memory is for the apps itself, which are authorized to run and consume this. Everyone else outside of that enclave boundary, it is always encrypted. So with that case, what can we assure? What can we claim with confidential containers or generally enclaves or SGX apps, right? This is an SGX protection boundary, and there are other related services on the AMD space like SEV-SNP, which have a slightly different security assurances, but I'm talking specifically on Intel SGX protection. So with this, you could claim that Kubernetes admins cannot have access to the data. They can do memory dumps. Hypervisor admins, the same. If there is an attack on the hypervisor layer, you are still protected. You're protected, obviously, from the cloud admins like Azure. Azure cannot see what's happening there or cannot even look into in any form or fashion what are happening. Another key thing which I did not call out in the previous slide was the guest OS. Right? If you have a Ubuntu system or a Red Hat OS that's running all of your containers, anyone can kind of drop in a malware there or add a buggy code, which may be doing some memory shorts or latching onto a process without you being aware of it at all, right? So we consider this as another big, huge area for us to cover. And this is what you're protected against. And it's also about other containers in the same node also protecting the subject container. This is what confidential containers gives you. I think the previous presenter spoke about confidential computing. We were the founding member of this, and we contribute quite a bit open source projects around this, and we have a good governing body which we are a member of as well. So this is really great to see, and we are really proud of what CCC has done and what it can do in cloud native space as well going forward. Okay, I'll quickly touch on the how part, but I think I want to really spend time on where. So I think this is how the traditional enclave apps really work, right? So you have an untrusted part which launches an enclave, and it says everything in an enclave can be measured and can be trusted, and any code that needs to be processed will process in an enclave. This is really good model if you're writing your apps to run on SGX specifically. But if you are a customer who has already developed a Java app or a C# app or a Python ML models, you don't have this leverage to rewrite your apps, right? It may be costly. That's where confidential containers comes. Confidential containers is about enabling you to do a lift and shift of your existing container to run on SGX type of a trusted execution environment. And when you go with this, and I'll just quickly go over what that process looks like, but the way this executes, this is the beauty of SGX, right? So when a container launches your Redis cache or a Java, Java app, it directly executes its instructions to CPU. So if you look at traditional execution methods, it always goes through the operating system and to hypervisor and then to CPU. But with SGX and confidential containers, it directly executes to CPU. So it's skipping these additional layers that you don't have to trust anymore. The only thing you need to really trust is your code that is running in your execution environment and the CPU or the chipset. And they both are part of the attestation, right? When you attest, you can attest it is running on a genuine Intel chipset and the code that is loaded and the signature of the code as well to just make sure the code integrity is in place. Right, and that's where that's very specific to code integrity, right? You can sign your application, and you can check that signature, the Amar signer, as part of the attestation itself. Okay, I think I wanted to skip this slide, but I just wanted to show you there are really foundational things are removing layers and attestation. Attestation is kind of the backbone of how we think about confidential computing generally. I'll skip this part about hardware CVMs. Okay, just jumping into the where pieces to this. There are plenty of use cases you have seen. There's amazing innovation happening with partners in moving this needle forward. But we kind of boil down to these top scenarios we continue to see. Right, you have privacy preserving analytics, which is very relevant, and I'm going to show you a couple of slides on architectures as how companies have tried to solve this. Like as big as RBCs and or even in the retail industries or even in the manufacturing, a lot of use cases in that. So for almost 3 to 4 years, we have collected so much of data. We have built amazing ML models, but we have kept it to ourselves, right? Like within our company boundaries because of the sensitivity of the model and the data. And now it is time to start collaborating at a larger level, like all banks to banks for anti-money laundering type of a scenario, or multiple parties sharing sensitive information without leaking any trade secrets, right? All of that is really enabled through confidential computing because of the assurances you can make with the hardware itself. You have payment processing gateway in the financial, because if you have tokenization and credit card information you are processing, it's all in plain text, right? Or even banking information is in plain text. So this is about how do you protect from your internal administrators type of scenarios. Blockchain ledgers, I think the speaker previous to that, they've used the blockchain. This is becoming getting a lot of traction on how you're running blockchain, especially the keys that are used for chunking your block transaction, like 10 keys generated in an enclave and a record is put together. That's the use case for blockchain. Inferencing and federated learning, I think this is obvious also because of the type of data. And I was just talking to one of the COVID-related projects that we are working actively on. How do you do a federated training between multiple hospitals in Europe, and kind of open source that model, right? It's in the same exact space. This is possible because people can trust the technology and the assurances it can provide. Key management. Interestingly, I've seen a lot of customers go this route of choosing like a replacement to their HSMs. I wouldn't call it as a replacement, but an alternative implementation to key management, right? They feel SGX enclaves are most secure, most trusted to generate the crypto materials and the keys that are required for any transactions, instead of using traditional HSMs, which are hardware security modules. And interestingly, some customers have even got approval for using this as a full replacement for their HSMs. So, and the last one is the databases, right? Because with the database, it's always about the memory for Redis, SQL Memcache, and all that stuff. SQLite and Memcache. Okay, so let's look at the MPC, multi-party confidential use case. This is a real use case I've been working with. I cannot use the customer name. We'll probably talk about it for a few months from now. This is about how every party can bring their ML model and can bring their data together to compute confidentially. And if you look at, there are trusted executions, there are untrusted executions. Think of a sequence of things that will happen, right? So this model does some data massaging first, and then puts in this information to a blob store, for example, where another model picks it up, but this model is coming from one party. And the model itself is secured, like you can encrypt the container. Uh, you can also encrypt the data, obviously, which is what it's going to process. And you can lock in the keys to this container. This is possible with secure key release functionality, which is something new in the MHSM Azure Key Vault. And you basically do the same thing, right? You have multiple parties bringing different models. Um, then you have the output data, and all of this is rich data. That's the key thing, right? It's not anonymized data. This is the rich data and the rich output that your business needs. This is an example of it. An extension of that is what one of our customers and through a partner who did this. This is for Magnet. Magnet is, I think, Russia's largest retail company. And Agrigen is a partner who implemented this through their solution. If you look at ATOL, Atoll is a data supplier, right? This is the credit card payment processing gateway. Magnet it has the rewards program. They work with their customers in enabling targeted targeted customer related conversations they want to do, or even marketing if they want to target that. And this is about how Atoll was able to bring confidential data with and merge it with Magnet to get rich insights that they could use for understanding more about their customer behavior. Right. So this was an implementation. This use case is already public. You can go read about it. Another scenario. This is about how multiple parties came together to establish trust, especially in the healthcare industry, right? Because the healthcare are very highly regulated. So here is a hospital. Hospital is running a SaaS type of an application, or an application that is hosted by a medical platform. And a medical platform needs to work with a diagnostics provider. And the scenario here is you have the X-rays or MRI scans. This sample is available on GitHub. You can send that to the Contoso. Contoso established trust with Fabricam through attestation. And the end party, which is Lumna Hospital, establishes the full trust to end all the platforms and the hash value and the code that was expected to receive this was all transparently attested through the client application, which is the web browser, really. Right, so it does all of those checks, and then the checks and the attestation goes through. That's when the image gets uploaded to this application. The image gets indexed, and the image gets sent to another provider to do inferencing, because Fabricam doesn't want to give away their ML model. They run a SaaS service, and they were able to come back and say there is like 70% probability based on this MRI scan that this patient has tumors, or we see pattern of tumors, for example. This is actually one of the hospitals really went this route to establish trust between multiple parties. Okay, this is built on Kubernetes, leveraging some components as you see here. It's also leveraging one of our partner, which is Scone or Scontain, who have really amazing products in the cloud native space. Okay, another scenario. This is data processing pipeline. So if you This is for a banking company who really are into Apache Spark and Spark Stack doing data processing. So what we did here is we took the container, the Spark container. We ran it on Kubernetes cluster, which is confidential computing enabled on SGX. And we created Spark jobs that would read the data from a blob, and it also reads the data from SQL, and it also pumps the SQL to Azure SQL. So this is a new product that is built on top of Azure confidential computing capability. This is called a SQL AE, always encrypt. If you look at how SQL always encrypt works, it's every column, any column you say this is a PII information, there is an encryption that happens. And the decryption and encryption process of that always happens in an enclave. So if it's a social security number, if the column is encrypted and it's using SQL always encrypted, that is running in an enclave. So all of that process of doing encryption and decryption happens in an enclave, right? So that's the product which gives you that full end-to-end capability to light up a scenario, right? We're not giving you compute and asking you to figure out what your data stack is going to look like. We are enabling you for a full end-to-end scenario, and this is what it is, right? We also Key Vault. Key Vault MHSM is a newest SKU. It went GA. This is also built on confidential computing hardware. So any assurances that SGX provides, like I called out, these two services are also able to call that out, including Kubernetes, because it's a node that can run your stuff. So this is like how end-to-end things can come into picture to light up your use cases, to move your scenario forward, just not your compute. Okay, so with that, that's my end of the where part to it. And if you're really interested what the deployments really look like and what is my developer flow, let me really spend a few minutes here, right? So this is just the capability of Azure Kubernetes service supporting confidential computing nodes, and here are all some features, but this is all a GA product. You should be able to read it on the docs. This is how your real AKS cluster may look like. You have an existing AKS cluster running standard nodes, nothing different. You will add another node of a confidential computing type, and you can target your deployment through YAML to run these containers specifically on these nodes. That's it. There is really nothing much for your operations to do. So it's a ultra lightweight for existing AKS clusters, or you create a net new AKS cluster. This is how it looks like. So this is your application developer flow. All right, this is how traditionally you do now. The delta to confidential containers is, as I said, because it uses a different programming model and execution model, it needs SGX runtime wrapper software. And this is open source projects like Graphene, Oculum, Mysticos, Edgeless. Any of those you can choose to wrap your runtime, your existing container, or you can choose an ISV to really do this. And it's a very simple process. It's just a CLI tooling where you say, here's my Docker file, build a SGX container. That's it. So it's a change in your CI/CD process is how I see. And it's still a standard Docker container, but it has the SGX awareness injected to it. Like it could be like a base image that it's using is different than you traditionally use for building your apps on. And your deployment, as I said, is pretty straightforward. You add a node pool and you just say, target this to that node pool. So this is my end of my presentation. I'm happy to take any questions at this time.
Any questions from the audience?
Yeah, so do you hear me?
Yes.
Yeah.
Okay, great. So I was much interested in the attestation part, which you actually skipped. So maybe you can say a bit about the attestation part. So
let me switch over to that slide. Yep. Okay. All right, so this is the attestation flow. Okay, and what is really an attestation in a nutshell is you want a cryptographic evidence that this is what is the environment, what's the patch level, what's the Intel, is this an Intel genuine chipset? Is this the code I can trust? Is this the code I signed? Right. So there are like 3 layers to it. Like there's platform, there is hardware and silicon, and there is application. All of that is part of the attestation. So this is a flow for Microsoft Azure attestation. There's always a remote party who's challenging the applications running in SGX to say, can you prove who you are? And for that to happen, this party can say, hey, give me your evidence first. And this, we call it as SGX quote. And you take that evidence, send it to Microsoft Azure attestation and say, Microsoft Azure attestation, can you check and tell me if this looks okay? And the Micro Azure attestation says, yes, I think we verified the root of trust chain and everything checks out. And here's also the Amar enclave and Amar signer details. Amar enclave is the hash of the code that got loaded. And the signer is who signed this application or a binary, right? And you can check all of that at the relying party and say, hey, can this be trusted? If it is, then you can transmit. You could also do this transparently using a mutual TLS as well. So you can establish this trust between the SGX apps through mutual TLS, or what we call it as mutually attested TLS. Okay. Does that give you enough, or do you want me to go a little more into details or questions?
Yeah, so maybe I will be more specific. So when so I'm aware of this this SGX part of attestation. So SGX creates that code. That's fine. So can you maybe elaborate more about this Azure attestation code that you generate?
It's yeah, Intel attestation service is very comparable to Microsoft Azure attestation. The only difference is the response from the Microsoft Azure attestation is also signed by the Microsoft, so you can go back and check if there has been any tampering or not. So in a nutshell, they both are the same. There are some advantages of Microsoft Azure attestation because like if Intel enforces the platform software components and when they expire, we give you a little more time. And if you're running on Azure, then Microsoft Azure attestation is a better place for you to be because of we know what our patch levels are on our machines. We may be ahead because of some vulnerabilities that may have happened, and would have already patched before we make any public statements. Those are all the advantages of Microsoft Azure attestation. But in a nutshell, Intel attestation and Microsoft Azure attestation are the same services.
Yeah, but so what I'm maybe missing is that how does Microsoft confirm that this is Intel enabled machine? So that I guess should come from Intel, right? So as in APID, enhanced privacy identification, it happens that Intel, the relying party, has to contact Intel for the verification that yes, it was a genuine, up-to-date SGX machine. So probably, so what I'm missing is this part, that how does Azure attestation service assure that it's actually a genuine machine? And as far as I understand, you are saying that this attestation is very much like SGX, but is an alternative and not something on top of that, right? Is that
correct?
true?
It's an alternative, but we directly, when you make an attestation call to Microsoft Azure attestation, it goes back to Intel PCK caching service, and it verifies the authenticity of the certificate root of chain established back to Intel, and it confirms all of that in the back end. So we go back and we have caching services from Intel that we go tap into to make sure this can be attested. And I can connect you. Yep.
I think now I get it, that it's still happening the same in the background.
Yes.
But the relying party only needs to communicate with the Azure attestation.
That's
right?
correct.
Is that
yes?
Okay. And
Yes.
and just a short question regarding this. So as you mentioned, I guess you are using, because you mentioned PCK certificates and all that. So basically you are using this data center attestation primitive.
Yes, yeah, decap. Yes.
Okay. Yes, that makes sense. That's fine. Yeah. Right.
Yeah, decap primitives, that's correct. And yeah, we have Intel PCK caching service on our side, which keeps up to date on all the new chips out there and whatever is happening in the SGX. We know that this is a genuine device or not, because as I said, we could definitely verify that. I think yeah, this service is already in GA, and I'm sure there is enough good technical documentation. And please leave us an email if you want to connect with the Microsoft Azure Attestation team, who can really represent this much better than I can.
Sure. Thank you very much.
Right. I think if there are no other questions, we are on top of the hour. Thank you very much for attending. I'm going to publish the recording of this session on YouTube. Thanks, Amar, one more time. Have a great day. See you next time. Bye.
Thanks, Stefano. Bye.